Hello and welcome back to Steven Data. Before watching this video, I want you to watch our previous video if you don't, because our videos are uploaded in order both in the video list and the YouTube playlist. And if you don't watch those previous videos, you may miss some valuable information. Anyway, you might remember that in the last video about probability, we talked about random experiment and sample space. In this video, we are going to talk about events that are actually subsets of a sample space and their operations like union, intersection, and complement. This video is a little shorter compared to other videos on this channel, and the reason is I want to keep similar subjects in one video, and event is the last term we are about to talk about in this section. In the next section, we will start learning counting techniques. Okay, I talked a lot. Let's dive into the video to see what actually an event is. After knowing the sample space of an experiment, we might be interested in a collection of related outcomes. In probability, these related outcomes are actually a subset of the main sample space, and this subset is called event. In other words, an event is a subset of the sample space of a random experiment. We can also be interested in describing new events from the combinations of existing events. Because events are subsets, we can use basic set operations like I just mentioned, such as union, intersection, and complement to form other events of interest. But now, before diving into the examples, let me clarify these three basic set operations for you. The union of two events is the event that consists of all outcomes that are contained in either of the two events. We denote the union of E1 and E2 as this. The intersection of two events is the event that consists of all outcomes that are contained in both of the two events. We denote the intersection of E1 and E2 as this. And finally, the complement of an event in a sample space is the set of outcomes in the sample space that are not in the event. We denote the complement of the event E as E prime. The notation E superscript C is also used in other literature to denote the complement. I know that they are easy to understand, but always remember it. Practice makes perfect. Consequently, let's see some examples of these operations. Consider the sample space S, which has four outcomes of yes, 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 no, no, yes, and no, no. Suppose that the subset of outcomes for which at least one camera conforms is denoted as E1. Then E1 has three outcomes of yes, 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 no, and no, yes. The event such that both cameras do not conform denoted as E2. Thus, E2 contains only the single outcome, which is no, no. Other examples of events are E3, which has no outcomes and it is called the null set, E4 equals S and it is called the sample space, and finally E5, which has three outcomes of yes, no, no, yes, and no, no. As I said, we can also have events which are made by the combinations of other events. For example, the union of E1 and E5 equals S. The intersection of E1 and E5 has two outcomes of yes, no, and no, yes, and E1 prime equals a set that has one outcome of no, no. As you may have noticed, our example was about a discrete sample space. Now, it's time to give you an example about the continuous one. In camera recycle time example, which I talked about it in the last video, camera recycle times might use the sample space S equals R plus, which is the set of positive real numbers. Let E1 be the set that X is between 10 and 12 in it, and E2 be the set that X is between 11 and 15 in it. Then, the union of E1 and E2 is the set that X is between 10 and 15 in it. The intersection of E1 and E2 is the set that X is between 11 and 12 in it. Also, even prime is the set that x is less than 10 or bigger than or equal to 12. And finally, the intersection of e1 prime and e2 is the set that x is between 12 and 15 in it. You may say none of the definitions nor the examples were hard to catch. To some extent, you're right, but never judge a book by its cover. This simple term can have more challenging problems like the following one. This table summarizes visits to emergency departments at 4 hospitals in Arizona. People may leave without being seen by a physician, and those visits are denoted as LWBS. The remaining visits are serviced at the emergency department, and the visitors may or may not be admitted for a stay in the hospital. Let A denote the event that a visit is to hospital 1, and let B denote the event that the result of the visit is LWBS. We want to calculate the number of outcomes in the intersection of A and B, A prime, and the union of A and B. The intersection of A and B consists of the 195 visits to hospital 1 that result in LWBS. The event A prime consists of the visits to hospitals 2, 3, and 4 and contains 6,991 plus 5,640 plus 4,329 that equals 16,960 visits. The union of A and B consists of the visits to hospital 1 or the visits that result in LWBS or both and contains 5,292 plus 270 plus 246 plus 242 that equals 6,050 visits. Notice that the last result can also be calculated as the number of visits in A plus the number of visits in B minus the number of visits in the intersection of A and B. And by that I mean 5,292 plus 953 minus 195 that equals 6,050 again. Apart from all these definitions and examples, there is a question left. How we can show events? Is using curly braces the only way that we can show them, or there are other ways that can depict events as well? In the answer to the question, I should say, of course there are other ways that we can use to depict events. Using diagrams is one of those ways. Diagrams are often used to portray relationships between sets, and these diagrams are also used to describe relationships between events. We can use Venn diagrams to represent a sample space and events in a sample space. For example, in this figure, the sample space of the random experiment is represented as the point in the rectangle S. The events A and B are the subsets of points in the indicated regions. These figures illustrate additional joint events. And finally, this figure illustrates two events with no common outcomes, which I will talk about it later in the video. These diagrams may seem a little complex, but don't worry, by throwing some light on them, you can get more knowledge about them. About this diagram, you may ask, how did we lead to this shape? Good question. With the help of a law which is called distributive law between sets that can be shown like this. About this diagram, you may ask again, how did we lead to this shape? In your answer, I would like to say with the help of the De Morgan's law, which says the complement of an expression like the intersection or union of two events not only affects the events but also the operation between them. And about the last shape, whose sets do not have common outcomes, I should say these sets are known as mutually exclusive, which can be shown like this. But before wrapping up the video, there are two additional points that knowing them can be helpful. First, we should know that in intersection and union, sets can be used interchangeably. I mean, A union B is not different from B union A, and this is also true about the intersection of them. And second, the complement of an event is equal to our main event, and it can be illustrated like this. Now it's the moment to wrap up the video. First, we learned that in some cases we are interested in specific sets of outcomes of our sample space. These subsets are actually called events in probability. Then we get some knowledge about the basic operations between events like intersection and union. And finally, we learned some useful laws like De Morgan and distributive law between events that help us solve complex problems. And that is done. Congratulations! Now you know some information about events in probability and you are able to solve relatively complex problems with the help of them. At last, if you like the video, please hit that like button, and if you are interested in this type of topic, please consider subscribing to this channel because these two keep me motivated to create these kind of content. By the way, if you have a question about this subject and anything related to probability and statistics as well as data science, comment it down in the comment section. I will answer them as soon as possible. I hope this video helped you a lot, and until the next video, happy learning!